Many students will begin by setting up the following multiplication and doing a series of longer multiplication calculations, much like the following. They'll set it up. 8 times 4 is 32, carry the 3, 8 plus 3 is 11, and the rest are zeros, and that's it. So I now have 1, 2, 3, 4, 5, 6. So I'll put in 1, 2, 3 more decimals to make 6 digits to the right of the decimals, and that would be my result. Now I actually have to take that and do my next calculation, 0.3, and keep track of my decimals. And this one's actually not too difficult in this case. It's 3 times 2 is 6, 3 times 1 is 3, 3 times 1 is 3, and I will actually have 6, 7 decimals, so that means I have to put in 4 additional zeros before my decimal, and that would be my result. So not too bad in this case, but as you can see, as it quickly gets more complex and difficult tracking the decimals each and every calculation over multiple calculations, especially if the numbers are harder to compute. Another approach we recommend is the following. First, convert the decimals to integers and then do your multiplication. So in this case, the 0.008 would become just 8 times 14 times 3. Much easier to multiply out the integers. 8 times 14 is 112, as we just saw, times 3 is going to be 336. And the procedure is not too different, but it's a lot easier to do it in 2 steps, multiplying the integers, and simply then add back the decimal. And we do so as follows. We count up all the digits to the right of the decimal points, 1, 2, 3, 4, 5, 6, 7, and I'll put 7 places back from 336, so my result will be 336, and I'll have 1, 2, 3, 4 more places for my decimal point, which will leave me, again, 4 zeros. And we arrive at the same result. Multiply out integers only, which is generally more reliable and easier for many students, and you simply add up all the decimal places at once and add that back to the result, as opposed to continually keeping track of your correct amount of decimals in the decimal position. So the fewer calculations, ideally, and the placement of the decimal should, in essence, be more reliable, and hopefully that tip will help you. Division can get even a little bit more tricky and complex and be prone to more errors than multiplication. We had the following problem, 1.44 divided by 0.08 times 0.009 in parentheses. Students might begin by trying to do long division. They'd start with 0.08 and divide that into 1.44. Well, that's a little messy right at the outset because we're dealing with decimals. So again, much like the multiplication, the trick is to convert your denominator to an integer if it's a decimal. So in that case, I will make my 0.08, I'll shift the decimal point 2 places to the right to make it 8. And if I do that in the denominator, I must do the same thing in my numerator, otherwise my fraction value will change. So I will have to move that decimal point 2 places to the right as well. That becomes an integer division of 8 divided into 144, which is easier for most students to process. And once students complete that long division, well, then they're going to have to divide 0.009 into the result. And they could take the same procedure and convert 9 to an integer and adjust the numerator again. But as you can see, we're doing long division after long division, which is another opportunity after another opportunity to make a mistake. Instead, let's convert everything to integers at the outset as follows. And in the numerator, I moved 2 decimal places. So that's essentially 10 to the negative 2 times 144 equals 1.44. And the denominator, I've got 1, 2, 3, 4, 5 decimal places in total. So that would be equivalent to 10 to the negative 5. And I'm going to separate my powers of 10 from my integers to make my calculations more easy. And now I'll factor. I'll notice 144 is essentially 2 times 72. And I know 8 times 9 is 72. Right away, I can see an opportunity to cancel from top to bottom, numerator to denominator, my 72s and just get a result of 2. My powers of 10, 10 to the negative 2 divided by 10 to the negative 5 is 10 to the negative 2 minus 5, which is essentially plus 5. So I'll be multiplying that result by 10 to the positive 3. And now my calculation simply becomes 2 times 1,000, which is 10 to the third, or 2,000. So in this approach, I've entirely avoided long division, first converting my decimals to integers. By separating out my integers and powers of 10, I can begin to cancel, factor if I need to, and cancel numerators and denominators to simplify my expression. That makes my resulting calculation a lot simpler, if not a non-event, as in this case. Let's try another example that's even more complex, with multiple decimals in the numerator being multiplied and in the denominator. So again, I'm going to try my first step and convert everything to integers. But when I do that, I'm going to have to keep track of my total powers of 10. And I'll do that for numerator and denominator. So in my numerator, I have 6.3 times 0.4. That'll simply become 63 times 4. And I know that I've got 2 digits to the right of the decimal, so that's effectively 10 to the negative 2 power, or 0.01 for the 2 decimal points. And in my denominator, it's going to be 7 times 18 times 2, and I've got 1, 2, 3, 4, 5, 6 digits to the right of my decimal, so that's 10 to the negative 6. And I can actually separate the powers of 10 from my integers to make the calculations much easier. So now I can look and try to cancel top to bottom, noting the factors. 63 is 9 times 7, so I can essentially cancel my 63 and 7 and make that a 9. My 4 and 2 cancel, that becomes a 2. So if I rewrite that, that's 9 times 2, and of course my 2 will cancel the 18, and I can make that a 9. So it's 9 times 1 now, divided by 9, or this is essentially just 9 divided by 9, or 1. So I have 1 times 10 to the 4th, that is just 10,000. And that's my answer. I avoided any complex long divisions, which are opportunities for making mistakes. So I converted to integers, I separated out the multiples of 10 by counting up the different decimals, and did those calculations separately to get hopefully a faster and more reliable result. Last but not least is addition and subtraction. Might be the easiest part of all. It's almost always easier to arrange the addition, or especially the subtraction, in vertical columns where each digit place is arranged vertically. For subtraction, it's again a good idea to arrange your numbers, especially your columns, vertically. But in this case, make sure to put the largest number on top. If you need to change signs afterward, as in this case, because you're taking 3.5 minus 7/3, a larger number, you can do so at the end. And that makes the actual subtraction a fair bit easier and more reliable. Lastly, when dealing with decimals, and in general, it's often good to know how to make quick, accurate estimates and to round. Rounding, just remember, 0, 1, 2, 3, and 4 round down. 5, 6, 7, and 8 round up. Now, the one that students often forget is 5. Because they think it's in the middle, they're not sure which way it rounds. But remember, we're starting with 0, so 5 is in the top half. It will round upward in every case. So, how do we use this to make estimates? Well, real quick, if I were to look at this figure and try to assess roughly what value the result is going to be, I can use that as a common sense check against my actual answer. More often than not, students forget to check that I get a negative result, but wait, the result can't be negative. Or I have a small value as a result, and it probably should be in the thousands if I were to estimate it. So real quick estimations can be very helpful to help you check and verify that you're more accurate in your solutions. Because let's face it, everybody at some point, good students and not, will make some mistakes in their calculations. So real quick, if I were to look at this one, I would say 290 is about 300, rounding to the nearest hundreds. And 0.447 looks an awful lot like 1/2. So I have two numbers that are easy to quickly manipulate in my mind, and I can see my answer is going to be something like 150. The actual answer should be less, which is in reality 129.63. The next one I'll look at, 9.34, that roughly looks like 10 to me, divided by 0.08 looks almost like 0.1. So I can quickly see my result is probably going to be about 10 divided by 1/10 is essentially 100. Again, two numbers I can quickly manipulate in my head. And I know the number is going to be a little bit higher because the 8 integer value is less than the 9 integer value. And in fact, the real answer is 116.75 in this case. But the moral of the story here is that a good quick estimate with numbers you can easily manipulate will help you assess whether your answer is in the ballpark of what you expect. And that's just another way to be more reliable in your results.